Assalamualaikum everyone, I'm Muhammad Izni Najmuddin. So imagine if scientists today still recorded every experimental result manually in notebooks and calculated everything by hand. Experimental data is one of the most important foundations in analytical chemistry because every scientific conclusion depends on the quality of collected data. As science and technology evolve, experimental data also underwent major transformation from simple observation to intelligent digital systems. In this presentation, we will explore how experimental data has evolved and how this evolution has improved scientific research and analytical chemistry. Before we explore how experimental data evolve over time, we first need to understand what experimental data actually means. Experimental data refers to information collected during experiments through observation, measurement, and analysis. In simple terms, it is the evidence scientists gather in order to answer a scientific question and make reliable conclusions. In analytical chemistry, experimental data plays a very important role because every result obtained from an experiment must be supported by measurable and reproducible evidence. Without proper data collection, scientists cannot determine whether a result is accurate, valid, or simply caused by error. Experimental data generally consists of two categories, which is qualitative data and quantitative data. Qualitative data describes characteristics that are observed but not measured numerically. This includes changes in color, odor, texture, appearance, or formation of precipitates. For example, during a chemical reaction, a solution changing from colorless to blue is considered qualitative data because it provides descriptive information about the reaction. On the other hand, quantitative data involve numerical measurements obtained through analytical procedures and instruments. Examples include concentration, mass, pH values, absorbance readings, and reaction yield percentages. Compared to qualitative observations, quantitative data allows scientists to compare results, perform calculations, and evaluate precision more effectively. As analytical chemistry continued to develop, the way scientists collected both qualitative and quantitative data also evolved. Data collection gradually moved from handwritten observations and manual calculations into highly precise digital system capable of processing thousands of measurements automatically. And this transformation became the beginning of the evolution of experimental data.
Traditional experimental data refers to data collected using conventional method through direct observation and manual process. Before digital technology became common, researchers mainly rely on paper records and visual observations. There are three main characteristics of traditional experimental data. First, information is recorded by hand. Second, calculations are done manually. And third, researchers depend on visual observation to collect and interpret data. Humanity spent centuries writing things down and hoping nobody spilled coffee on the notebook, a remarkably optimistic strategy. However, traditional methods have several limitations. Human errors can occur during recording or calculations. The process is also slower because each step must be done manually. In addition, storing and managing paper records can be difficult and inefficient. Examples of traditional experimental data include laboratory notebooks, field observations, paper-based survey, and manual measurement. The workflow starts with planning the experiment, followed by collecting data, recording and calculating the result, analyzing the finding, and finally storing the data. Although traditional methods have played an important role in scientific research, modern digital techniques are now preferred because they provide faster processing, greater accuracy, and easier data management.
Hi everyone, my name is Zahin Daniel. I would like to explain to you guys about the instrumental revolutions and digital transformations. So first, what is instrumental revolutions? Instrumental revolutions is a period when scientific research shifted from manual observation to instrument-based data collections. The development of advanced instruments is allow scientists to collect data more accurately and efficiently. For example, the spectrophotometer measure the absorptions of light by a sample, while chromatography separate different components present in a mixture. In addition, the pH meter acts as an electronic detector that measures the acidity or alkalinity of solutions. From these technological advancements, it's really significantly improved scientific research by increasing the precision, sensitivity, and the reproducibility of experimental results. Next, I would like to explain to you guys about the digital transformations. With the advancements of technology, experimental data management shift from a paper-based record to digital system. Researcher begins using computers to record and process experimental results more efficiently. This data could then be stored in a database, allowing easier organizations and retrievals. So today, cloud-based platform enables researchers to access, share, and also collaborating on data from different locations. As a result, digital experimental data provides electronic storage, automated calculations, and improve the data sharings, making scientific research more efficient and reliable. That's all from me. Thank you for listening. I'm now hand over to Darwisha for the next explanations.
Hi everyone, my name is Darwisha Mansar Abidi Ikmal. So now let's look at how modern experimental data is analyzed. With the advancement of artificial intelligence and big data, scientists can process large amount of experimental data much faster and more accurately than before. First, we have machine learning. Machine learning allow computer to learn patterns from thousands or even millions of chemical data without being directly programmed for every task. Instead of scientists analyzing every result manually, AI can identify patterns, classify compounds, and even predict the properties of new chemicals. This improves analytical accuracy while saving a lot of time. For example, in drug research, machine learning can predict whether a newly designed compound might become an effective medicine before extensive laboratory testing. The second method is statistical analysis. Statistical analysis helps scientists organize and interpret large data sets collected from experiments. It allows researchers to identify trends, compare different experimental results, reduce error, and ensure that conclusions are reliable. Without statistical analysis, it would be more difficult to know whether the results are truly significant or simply happen by chance. The third technique is predictive modeling. Predictive modeling uses existing experimental data to predict future outcomes or behavior. This means scientists don't always need to repeat every experiment because computer models can estimate the expected result first. As a result, research becomes faster, less expensive, and more efficient. Now, let's look at some real-life applications of AI and big data in chemistry. The first application is drug analysis. In pharmaceutical industry, AI analyzes large amount of chemical data to study drugs composition, predict how medicine will perform, and maintain quality control. This helps ensure that medicine are both safe and effective before reaching the patient. The second application is food quality monitoring. AI system can analyze chemical data to detect contamination, monitor freshness, and ensure the food products meet safety standards. This helps prevent unsafe food from reaching consumer. For example, AI can quickly detect bacterial contamination in milk or meat during food production. The last application is environmental monitoring. Big data system continuously collect information from sensors that monitor air and water quality. AI then analyze this data to detect pollution, identify environmental change, and provide early warning before problems become more serious. For example, if pollution level in the river suddenly increase, AI can detect the change immediately and alert environmental authorities. Overall, AI, big data, and modern data analysis techniques have transformed chemistry by making research faster, improving accuracy, reducing costs, and helping scientists make better decisions in healthcare, food safety, and environmental protections.
Hi, my name is Haya Sada Metroslaini. So now, let's moving on to the future direction of experimental data in analytical chemistry. So the future of laboratory work is becoming more advanced with the integration of digital technologies. First, real-time monitoring allows scientists to collect and analyze data instantly, improving accuracy and decision making. Second, smart laboratories use artificial intelligence and connected devices to increase efficiency and also to reduce human error. Third, cloud integration enables researchers to store, access, and share data easily from anywhere, promoting better collaboration. Finally, automated experimentation can perform repetitive tasks automatically, saving time and also can increasing the productivity. So overall, these innovations will make analytical chemistry faster, more accurate, and the most important is can be more efficient in the future. As a conclusion, we can summarize that experimental data has evolved from simple handwritten observation to advanced digital and intelligent systems. This transformation has significantly improved the precision, efficiency, and also reliability of analytical chemistry. Understanding this evolution can help us to recognize the important role of technology in driving scientific progress. As a future scientist, it is essential to adapt to emerging data technologies to support innovation and also for investment in scientific research.